So this is the CNC for Beginners webinar to walk you through the basics of CNC routers. And I'm very excited to be doing this and very excited to be part of your CNC journey. So what I'm going to do is I'm just going to start jumping in on this. We are going to go through several topics, and then at the end of the topics, we'll be able to stop for a minute and do a little Q&A, and then we'll move on. So I'm going to share my screen now. And everybody should be able to see a big zoom. Give me a thumbs up if you can see that. Lori, okay, all right, we got it. All right, so I'm going to get into a presentation that I've put together for you guys. And so the webinar starts off. The topics that we're going to be covering is generally about your CNC router, obviously, but we're going to talk about how it works. I think that's important to understand the basics of CNC with your router, and then we're going to get into a little bit about G-code. We're not going to talk a lot about that because you don't really need to know a lot of that, but there will be a couple that you will want to know. And then we'll talk a little bit about design basics, router bits, and then setting up your jobs. And then at the end, we'll do a 10-15 minute Q&A, try to explain some things, answer some questions that you may have. Okay, so let's just start right off with how a CNC router works. So let's just talk about the components of CNC so that you understand the flow of how all this stuff works. So you see I've made a little bit of a flow chart here, and the first component of CNC is obviously the design. You'll hear the word CAD a lot, and what that means is computer-aided design as opposed to hand designing things. And so if you have easel or Vectric or Carbide Create, and you're working on building up your project in the design phase, then you're working in CAD. Now, CAD goes in many directions. It makes blueprints. It makes diagrams for other things, but in this case, obviously, it's for the amazing creations that you are going to be making. So this is Vectric, and your software is, if you're not using Vectric, you're still going to have many of these features. Over in this side of the screen is the CAD area, and that's where you're designing things up and coming up with amazing things like a sign that you may want to make. And let's come back to this. And then we have the CAM, and the computer, that stands for computer-aided manufacturing or computer-aided machining. And I'm gonna just switch the way I'm doing this a little bit. So in your software, if you're using VCarve, when you're done with your design and you switch over to your toolpath area, such as what you have here, this is computer-aided machining or computer-aided manufacturing, where you are directing the tool paths. Now, if you're using a different software like easel or Carbide Create or some other design software, that these may not be as prevalent. You may be dictating the router bits that you want while you're doing the design work. Easel, I believe, does that, where you draw a square and you'll pick the tool at the same time. When I say tool, it means router bit. So you're doing CAD CAM at the same time. And the CAM is, when you get down to the very bottom of it, CAM is actually doing your drawing work or your toolpath work. Whereas if I generated a toolpath here, let me go over here and just run all these out. I have to select everything. So this is the CAM aspect, and it's just doing, oops, yeah, so that's computer-aided machining. It's when we get into the next phase that your machine, it preps your CNC router to run. So all your design stuff is actually built with vectors and lines, or sometimes you'll hear the word STL file. That's like lots of little triangles that turn lots of different ways, creates an image. But up until the end of the cam area, it's just working in binary code. And so the CNC router works by the G code telling it to move in different directions, different distances, different speeds. And so those binary codes need to be transferred over to G code. And that's what the post processor is. You've likely heard of a post processor, but the post processor converts your binary to G code. And we're going to talk about G code next. And that's how your machine understands what it needs to do. And then you come over to your controller. Now, the controller is going to be like Mach 3, Mach 4, Universal G code sender. What those are doing, that's actually giving you a display of what your machine is doing. And I've got mine open here. So this is where you can actually control the movement of your machine. And now I don't know what software or what machines some of you guys have, but if you just have a machine where you have the black box, you plug in the USB into that box and hit a start button without having this kind of display, I don't personally like it because I can't necessarily see what the CNC router is doing, and I can't control it quite the way I want to. When you have a universal G code sender or Mach 3, Mach 4, you've got a lot more control over your machine. In these ones where the boxes where you plug in the USB with the G code on it, you're not seeing what's going on within the machine, and that's what this controller does. However, your black box is the controller. It is doing all the work that this would be displaying. Let's come back to this. And you notice that I've got a hashed line around the controller. And this is where things start to separate, because not all the controller can run any kind of machine. CNC for all intents and purposes for us, is typically a 3-axis machine. It moves in an X direction, a Y direction, and a Z direction. However, a controller can run a robot which has 6 axes or 5 axes, and you've seen robots contort all around, or can run a production machine that does multiple different things. In this case, the controller is what we are interfacing with our CNC router. And then we get to the CNC, which is the machine. And again, in our case, it's typically a 3-axis machine. You may have seen the ones with the rotary. That would be considered a 4th axis. I will actually be getting a machine very shortly. It's on its way. That is a 4th axis machine, so I'm very excited to get into that. So a CNC, for all intents and purposes, is simply a machine that moves around. It can be a 3D printer. It can be a laser cutter, a plasma cutter. So I think you have the idea that a CNC, this is the stop point where it starts to specialize. You see I have a red line right here. And this is where it becomes a CNC router as opposed to whatever it can be. Like I said, 3D printer or laser cutter, plasma cutter, milling machine, lathe. The next component is the actual machine that's going to be doing the work. In our case, it's a router. And a laser cutter, it's a laser. And a 3D printer is the melting head. So from there, it's all the things that actually do the work, the bits, the material, and your accessories. Now, when I talk about accessories, I'm talking about shields around your machine to keep it quiet, or vacuum systems, all the stuff that you don't have to have for your machine to actually do its work. So I think, are there any questions about what I've said here so far? People have a generally good idea of how a CNC, what the flow of how a CNC machine works and what it is? Okay. I thought this would just be an interesting thing for you to understand is how does your CNC machine know how to move from one specific point to another specific point? So CNC is driven by stepper motors. And a stepper motor is it has what's called a stator that's on the outside of the motor, and inside is the armature. And if somebody is making some noise there, okay. And on the armature is a lot of little, we'll just call them bumps. As you can see, this looks like a little gear. What those are magnetic poles. And the little arms on the stator are the magnets. They're electrical coils. And in order to make this armature move, a coil will be charged. And typically it'll be coils that are opposite each other will be charged. And what that'll do is that creates like a negative pole or a south pole or a north pole magnetic field, which pulls the armature. One of these, it pulls the little teeth, which are magnets, in line with the opposing field, meaning you know that a north pole is attracted to a south pole. And then this one would be turned off and the next one would turn on as far as being magnetized, and that would pull the armature a little further. And so it depends on the number of magnets that are in the armature. That would depend on what they call the resolution, or how refined that step is. That's why they call it a stepper motor. When one magnet turns on or turns off and the other one turns on, it's the armature steps over to the next magnet. And so the controller itself sends pulses to this magnet in the order of magnets. You'll see that your stepper motors, if you put like a Bob CNC together, that the stepper motors have 4 wires to them. And those wires are tied into these coils consecutively. So 2 wires would be tied into the up and down coil. The other 2 would be tied into the next coil. The other 2, the first 2 would be tied into this coil, and so on. And so the resolution or the fineness of the motion depends on how many coils you have and how many magnets you have on the armature. And then you have a gear or a pulley, or you may have a lead screw or a ball screw. And there's a lot of math that goes on to figure all that out. So I thought that you might want to know that how that knows how many pulses to move. And what your controller does is it sends those pulses to the motor at a controlled rate, so that the motor will move at a feed rate that you set up or at a rapid rate. So that's how your machine knows how to move. There is no feedback loop going back to your controller saying, okay, I've moved this number of pulses. That you'll find in like very expensive production machines, but not in the CNC routers that we have. So if you have a belt-driven machine and then your router is moving and something stops it, but the motor is still going, it is thinking that it's still going to that position, even though it stopped. So once that happens, then the whole system is off. You'll have to stop it, send the router to the home position by using home the machine button. And when you send that home, then it'll reset its position, and then you can restart your program. So G code, you as a CNC router owner have heard this, but may not know quite what it is. You won't use G code a lot, but you will use it when you manually want to move your machine. But I thought you'd be interested in knowing what G code is specifically and how it applies to your CNC router. So the term G code is a catch-all term because there's lots of codes that go into your CNC router, but G code is the one that's used the most. And so G code in the technical sense, when I say I'm going to type in some G code, I'm actually typing in G with some numbers behind it. G code is the commands that tell your machine where to move and how fast to move it to. But I'm going to show you a little bit further here. If you would open up your G code file, I'm going to bring up an example here. You're going to see something that looks like this. And it's just a bunch of gibberish that lots of numbers and letters that are compressed together. And I know this is a little small on your screen, but I have a bigger example for you. But you can see, well, let's go ahead and go to this other example. So this is an example of a G code file that I've modified and colored for you and separated things out so you can understand what is going on here. When you're looking at a G code file here, you don't just have G's in the front of lines. You also have like a T, there will be an S, we have an M, we have an F. So there's lots of different codes that are actually punched out from your post processor to create this G code file. Now I'm going to step back a little bit. I explained post processors before. Post processors are programs that convert the binary into this type of format. However, every CNC router brand has its own post processor. That's why if you have Vectric and you open up the post processor list, there's like 200 of them in there. That's because a post processor has been written for a specific machine, and so its output, which is what you're looking at on the screen here, gets punched out in a certain format. So going back to this for a moment, what you're typically going to see inside of your G code file are your G's, M, T, S, F, and you may see an N. So I'll explain what these mean. If you've looked at some of your files, we're going to get into G code in a minute. So the M, think of it as, it stands for machine. The M code is internal to your controller, telling the machine to do anything except for move. So M code is going to say, I'm going to start the program, I'm going to pause the program, I am going to turn the spindle on clockwise, I'll turn it on counterclockwise. When I say spindle, most of us have routers on our machine. And so you don't have this ability to like make it go counterclockwise, but CNC routers that have spindles on them have that capability to go forward or backward. And just so you know, where would a spindle come in handy is if you are tapping a hole with a thread, like a threaded hole. You need the spindle to drive that tap down in, cutting the threads, and then it needs to back up out of the hole. And so that's where you'd use a reverse spindle. You'll see F, and the F tells the router how fast it's going to be moving. So you'll see it in a case like F equals F35.0. And the last one is N. Now, N will always show up at the beginning of every line if your software is punching out N code. And what that is, that's just calling it out as a line number. So if we go to this example right here, the T1 right here is the first line number, so you would see N1. in front of it. The next line would be N2, and so on. It's just designating a line number. Now, I like my codes to have line numbers in them because if I run into a problem like with Universal G-Code Sender, if you've used it, you may have run into a point where it just stops and it's right in the middle of running the program. And so when you have a controller like Universal G-Code Sender or Mach 3, you have a display that's showing you the G-code that it's running at that moment, or the line number. And so, excuse me, if for some reason you have to stop your router or it stops on its own, you can look at your command lines like right down in here, and you'll see your G-code being scrolling across, and you'll be able to see what line number you're stopped at. And then you can send your machine home and do whatever you have to do to fix the problem, and then tell the router to go back to that line number. That's a little more advanced because then you have to edit your G-code to make sure it gets there in the right way. Then if you ever run into that, I'll be happy to help you out. So when you're looking at a G-code file, you're going to see some strange codes. The one you're going to see the most of is what is a G0 and a G1. The G0 tells, first of all code that starts with a G relates to motion of the machine. So it can be just a straight line, it can be in a circle, it can be tapping or drilling. There's literally hundreds of G code commands that are out there. But for all intents and purposes, the ones you'll want to remember are G0 and G1. G0 tells the CNC router that it is going to go in a rapid motion or as fast as the post processor has said it can go. Meaning, if I dictate in my CNC router, when I write the post processor, that the fastest it can go is 200 inches per minute, then when in a program, a G-code program, when a G-code is called up, it will never run faster than 200 inches per minute, but it'll run at 200 inches per minute. And then you'll end up seeing a lot of G1s. And the G1 tells it it's going to run at a feed rate. So when we set up our tool or our router bit in our library and we dictate a feed rate of 50 inches per minute, it's going to pull from that library and punch this F number in there with the 50 behind it. So in this case, it's looking at 30 inches per minute. That's what was in my library when it called up that bit. And from there on, you see there's a G1 in every line. That's actually not necessary, but it's not anything to worry about. It's just to understand G0 is a rapid move, G1 is a feed rate. Now you're going to likely see other things at the beginning of your G code. And so just so you're not like going, what is this? What does all this mean? You'll see a T, which stands for the tool number. For any of us, that doesn't matter. What that stands for is if your CNC router has multiple tools in it, where the CNC router actually goes and gets its own, does its own tool change. We have to stop it. We have to actually change our tool or our router bit. So this is really not a relevant thing. If you have a multiple tool, if you have what they call a tool magazine, then then you
Hey, brother.
Then you probably won't need to be here. Somebody have a question?
I'm on that webinar right now.
You got a what?
Yes, I have a question, Garrett.
Okay, give me a second. I gotta
ask you, can we go to church with you?
Okay. Who had the question?
My question is, when you have T1, so that's for like a manual tool changing. If you have a T1 and you need to change to the next tool. So you in a G code, you should have a T2 somewhere to. Is it going to stop or you? I mean, how do you manage
So,
that?
okay. So if you have what's called a tool magazine, where there's multiple tools in the CNC, it already has what's called a subroutine inside of it that knows when T is called up, it's going to go up and make the change. And it has like a pre-programmed routine in there. In the case of us, the software Vectric will not write programs as one program. This is where your post processor comes in. Okay, so the post processor for this one, which is a Bob's E4 CNC, it tells Vectric, when Vectric tries to write a program. Let's try to rephrase this. When I tell Vectric I'm going to convert this to G code, Vectric is going to look at the post processor, and the post processor is going to say, I've got 5 tools, or I can only handle 1 tool or 1 router bit. And so what it'll do is Vectric will say, the post processor is not letting me write this using 2 different types of router bits. So we have to write a separate G code file for that. In the case of like easel, carbide create, I got some background noise. I got to find out where that's coming in at. Give me just 1 second. I just want to get everybody muted here. Okay. Can everybody check their lower left screen and make sure your microphone is, there we go. Got it. Okay. If you have something like easel or carbide create, it's going to write the program in a way where the router is going to stop. Now, I've not messed with easel or carbide create. This tool change thing for companies that write these post processors for us, in this case, where how do we know when to change a tool? They have written a post processor so we cannot make one program with multiple tools in it. You have to actually load the next G code in it. And I am going to learn, I'm actually just starting to learn carbide create and easel, but these, like those 2 are written for people who don't know the deeper levels of machining. So,
Hey, Garrett.
yeah, did I answer that question first of all?
Yes.
Okay. So it's yes. Somebody said Garrett.
Yeah, Garrett, this is Jeff Lambert.
Hi, Jeff.
Hey, just a question about the post processor. I'm running a Bob's E4,
Okay.
and when I select the post processor, do I select the gerbil in inches I want to use, or Bob's E4?
Let's take a look. So I am going to see something there. I'm designing. So you want to select the Bob's E4.
Okay.
And the reason is, so that I got Bob's E4 here, and it's in inches. The reason you want to do that is because Bob's has had the post processor written for the E4, and if you use the gerbil, then I'm not sure what it punches out. I'll have to take a look as far as G code to see. But if you're using the E4, you want to use the E4 post processor.
Okay.
Because that post has been written for that machine.
Okay.
Yeah, it's kind of like uh, writing a program for a car, right? The car has an onboard computer,
Right.
and you have a Corvette and you have a Volkswagen Beetle.
Mm.
The Corvette is going to have a very different program to manage the fuel flow, the the airflow, as opposed to the Volkswagen Beetle. And it's the same way. If you try to put the Corvette program into the Volkswagen, it's just not going to run right. You're probably going to ruin the engine, and probably the same way with the Corvette if you put the Volkswagen program into it.
So even though Bob's uses Gerbil for their post processor, I'll still
Yeah.
select Bob's E4 because the Gerbil is a part of their post processing already. Or am I
Yes.
misstating that?
Well, no. So I am not absolutely 100% clear on the gerbil. It is more of a, from my understanding, I'm actually going to write that note down because I don't like to get caught with my pants down. GRBL.
Yeah, always a good idea.
Yeah. So, but gerbil is, I can't even really say. I don't know if it's a post processor or it's an after post processor, like this intermediary between the post and the controller. Where I see gerbil is when my controller is hooked up. I do have it
Yes.
on my computer. So
On UGS platform, that's the gerbil is selected there on the UGS.
yeah. So I will. I'm writing that down, and I will try to answer that question for you later.
Okay, thanks, Garrett.
No, I appreciate it. I always love getting a challenge, and I don't like having my pants caught down, but that's okay. None of us.
That wasn't my intention.
Nope, that's okay. You know what? None of us are perfect. And okay, so some of the things that you might see in your G code is something like a G17, a G20, G90, G54, which is punched out in mine. And so these are telling the machine that's going to work, it's going to move in certain ways. There can be multiple G codes in your CNC at one time. The G codes come in families or groups. And so you can only have one from a group that's actually being called up at one time. But you can have multiple different groups being called into it. And I have an example up here somewhere. Well, like right here. Okay, so you have G90 and G54. These can work together. But what we can't have is something like a G0 and a G1 at the same time, because they're part of a group. And they do that group differently. So the G0 says move as fast as you can. G1 says move at a certain rate. So those two conflict. And when I come back to my presentation here, so I've already kind of explained what you're looking at here, what G code looks like. So here's an example of groups. You have G0 and G1. There'd be another one, a G2 and a G3. That's part of that group. A G0 and G1 are rapid and feed rates in a straight line. You might see a G2 or G3, which means it's a circular motion that's going to be making. And then you have things like G90, G91. That's telling the machine that it's going to be working in what's called absolute or relative motion. And what that means is there is a known 0 point, the 0 point that you set with your machine. And all your G code is being written from that 0 point. And that's called absolute. So if it says I'm going to move to X1 and it gets there, and then it says I'm going to move to X5, it's going to start 1 inch from the start point, and then it's going to move 5 inches from the start point. Where if I use what's called a relative command and I did the X5, it's going to move relative to the position that it's at, which means it would be 6 inches away from the start point. I hope that made sense. That's getting a little bit out there but just so you know what you're looking at. you'll see G54, 55, 56, 57, and 58, and 59 are part of a group. And you will always see on your controller G54. I have a video out there that talks about this. These are used when you want to produce things. And then, of course, you have your M codes, which are telling your spindle to turn on, turn off, to stop the machine for a minute, to temporarily stop, to end the program. So there's lots of codes out there. So you can understand they work in groups. And for one thing that this G code tells it to do, there's always going to be like a sister thing that it tells it to do. And it's like the good sister and bad sister. They can't work together, right? Very different. Okay. Oops, no, I want to keep that up there. So at that point with the G code, is there any questions on that? The intention of this was just to kind of give you an idea of what G code is, and when you're looking at it, to understand that this is a program that your CNC controller understands how to do things. So now when you look at it, you'll have a little bit better idea. And if you ever want to know what a G code is, you can type it into Google and type in the G code number, and you'll usually get an answer. However, G codes have fallen out of standard somewhat. And so lots of different manufacturers use G codes for like the same G code for doing something completely different. So, but G0 and G1 are quite standard. All right, so design basics. We'll talk a bit about how to design things up and how to think about it when you're doing your design work. First, we'll talk about software briefly. You've heard of Vectric VCarve because that's what I talk about. That's what I use. There's another one called Carvico, and then there's Fusion 360. So these are the ones where you have a buttload of control over what how to design. You can really needle into specifics on your design work. Like Fusion 360 is more engineering based. Carvico is between doing cool designs and engineering, and then Vectric is really made for signs and making pretty things. But they're all very powerful programs, and as you move up the ladder or down the list, is getting more complicated and requires a lot more skill as you move down. Personally, I really like Vectric because it was written with the user in mind and kept with a good intuitive type of flow. Once that you start to get the way that they wrote it, you can just see how everything falls together. And then the two free ones that I know of are Carbide Create and Easel. Now, Carbide Create is owned by Shipoko, and Easel is owned by Inventables. And the Inventables is the X-Carve, the X-Carve Pro. You probably have seen ads of that on YouTube as you watch videos. And so those have free versions, and then they have pro versions. And the free versions are fairly limited, but you can do quite a bit of stuff with them. You can make a decent sign out of them. Like I said, I haven't fiddled with them too much, but I have toyed with them enough to be able to do a little bit of stuff. But I haven't actually had one generate a program for me yet, or G code yet. So the difference is, where do you want to go with what you want to do with your CNC machine as to whether you want to, which software you want to go with. Personally, I don't like to learn one and then have to learn another one. So I always go with what I think is going to be a really good global type of platform. And that's why I picked Vectric. I stayed away from Fusion 360 because even though I've been an engineer all my life, I'm not trying to do the engineering work. I'm trying to make amazing, pretty things. And let's see. So I was saying where you want to go with your CNC. If you are very intent on going into business with this, then you can start off with the freebies. But you'll find pretty quickly that you're going to start getting limited as you get more advanced in what you want to do. And so if you want to just make stuff, and you can make some decent stuff. But the other ones, just go with Carbide, Create, and Easel. Now, Easel is an online platform, meaning you can't run it if you don't have internet. I apologize for any background noise. I have an intersection here, and I live in an artsy town, so we get all the motorcycles coming through, cars with loud mufflers, and I don't know if it's coming through the mic or not. Carbide Create is not. That's an offline program. So with any of these, once you generate your G code and get it saved, it'll save to your USB, your computer, and you don't need to be online from that point on. So how many people here work with the free ones, Carbide Creator, Easel? Anybody? I can only see about 4 people at one time. So just scrolling through it. Okay. Your VCarve users or Vectric, Aspire?
I got Vectric.
Okay. Okay. So when I'm showing Vectric, then you know what I'm talking about. All right. So the thing with design, if you broke it down in its most simplistic sense, signs or design is working with nothing but lines, arcs, and curves. Okay, so an arc and a curve are 2 different things. An arc is a part of a circle or a complete circle. A curve has a little bit more I'm not sure of the word. So basically, obviously that's a line. An arc, when I pick 2 points and I come up here, it's basing it on a radius. So it's a part of a circle or a whole circle. And a curve is a variable circle. So in any design work you do, that is what you're working with. And I think that will help you simplify the way that you're looking at things, that everything is just lines, curves, and arcs. And every line is considered a vector, and every vector is either open or closed. So all 3 of these vectors that I've just drawn up are all open vectors, which means that they start and end in different places, whereas a closed vector starts and ends in the same place. So a rectangle is a closed vector, your star is a closed vector. And the differences are what you can do with it. So in an open vector, you can follow the line with your router bit, or you can follow next to the line, where you're basically following the profile of a line. And the closed vector, you can cut inside the line and clear everything out, or clear everything out of the outside of the line. So in this case, it's the box. A closed vector, you can carve everything away outside of that box. You can carve everything away from outside of the star or inside of the star. If you tried to tell Vectric that you wanted to do a pocket cut on one of these open vectors, it's not going to know what to do, because there's no closed vector here to cut. But if you told it you wanted to profile, then you could do it. So profile, I think some people got confused about that. I've had a couple of comments on my YouTube channel. The differences between profile and pocketing. So a profile is following a line. Pocketing is cutting inside away, cutting material away around a closed boundary. And a profile can be on the line, it can be outside the line, or it can be inside the line. You can profile an open vector or a closed vector. You just can't pocket an open vector. So,
question, Garrett.
Yeah.
This is Jeff again.
Hi, Jeff.
Hey, can you combine those on a project?
Yes. So that's going to take a little bit of thought. Does everybody understand nodes? I'll answer your question. I'll answer your question with this one. So, because this is part of this anyway, all lines and vectors, all vectors have nodes. and a node are transition points. So in Vectric, when I press the N button while that line is highlighted, I've got two nodes showing up, the start and the end. And then that third point is not a node. It's just like a transition in the node, or I'm not sure what I'd call that. But if I was to take that node and snap it over to the box like that, that vector is still a standalone vector. It's still an open vector. Okay, so if I clicked it, it's still considered open. Now, if I select the box and I try to merge them by using the close join the vectors, and I click it a couple times, let me just hover over that. It did not do it. What you have to do is because there's multiple lines coming into one node right now, it can't join those vectors like that. It has to be able to join one line to the other. And so in this case, you can join it, but you're going to have to separate the other node from the line. For example, if I wanted this arc to be connected to this part of the box, I have to tell it that this part of the line is no longer going to be part of this vector. And the way I would do that is basically highlight it, go to node, and hover over that node and hit the C button, and that'll cut that node away from that vector. So it chose to break it out from there. I'm actually trying to see how this works right now. And you can see it's still not attached. So now I've got to attach this vector to this vector by highlighting that and telling it to join. And now this one is part of that. I'm not sure if this answered your question, but so the question was, can I join it? I can join it, but it can't be joined with multiple vectors coming into one node. There can only be two lines coming into a node. Does that clear it up, or do you want me to re-explain that?
Yes, it does.
Okay,
Thank you.
you're welcome. So, okay, so we've covered everything there. Just remember, when you're designing, it's a line, arc, or a curve. And it's just how you're plugging them all together. And you can have multiple lines put together to create a closed vector, or multiple lines put together, lines, arcs, and curves put together to create closed vectors or open vectors. And so they're either open or closed. And if you want to do a pocket type of cut, you have to close your vectors. And that's where your nodes come in. Okay, so I think everybody here is using Vectric. So your most useful elements in any design software is the ability to snap using grids. You can see on the background of my slide right now has grids in here. And I use that to position all the stuff when I was building the slides. Grids enable you to snap to specific points. So with a snap turned on in your Vectric, the grid will, let's see, I almost never use grids. So grid function is the snap is this one and that one. And then you have the grid function. When I hit the grid, you can see the dots came up. And let's see, F4, I'm going to just try to bring my snap screen up. Cancel, Alt F4, there we go. When you hit F4 on your keyboard, you're going to get this menu up, and that's your snap menu. And you see right here, there's a selection that says snap to your grid. And so what that's going to tell Vectric to do is when you try to draw a line, it's going to give you that grid point as one of your options to snap to. I'll demonstrate that in just a moment. You can see below here is a number of 0.25. That number tells you how far away these snap points are from each other. So right now they're 1/4 of an inch apart. So the snap to grid is checked. And when I draw a line, now you know that if you've worked with this at all, you've got different snap points. So some of these dashed lines pop up. That's telling us that it's snapping to different points. And it's also going to snap to that grid point as well. And that I was not quite hovering over that snap point. I'm going to start that over again. And where's my grid? Right there. It's like one dot. I'm just coming close to it, but I'm not over it. And there, my cursor changed to like a cross. And that means it's snapping to that, to the grid. So grids are helpful if you want to just keep very accurate locations where your lines are going to. If you get into interesting designs, like this one that I had done, you might have seen the video, you don't, and you're actually drawing up the coffee cup, you don't really want to snap to a grid because you're going to start losing your shape, and then you'd want to turn your grid off. Layers. Now I've got a whole video on layers. I want to discuss layers a little bit just so everybody understands the usefulness of them. Did everybody see the video I made with clamps? If you didn't, you'll want to go watch it. I take advantage of layers so that I can do my machining or cutting the wood, setting it up to cut without having to work around other lines and vectors. Layers enables you to turn different elements on and off, and it helps you to design. Actually, a really good one is this one I am doing, and you're actually going to have a nice little heads up. This is a project I am working on right now, a flag, and I'll be doing a video on this once I've got all the aspects of it worked out. But I've got lots of things I'm working on in here to make it work right, and so I am using lots of layers so I can turn things off so that I'm not messing with other things. For example, if I want to change the size of these letters, I want the layer, the freedom layer of the hands turned off, so I don't mess with that. I might want to just turn the stripes off just so they're out of my visual field. And when I go over to generate toolpath, those different layers, I can turn them off so that I'm not trying to pick into different little corners and stuff like that. So yeah, layers are extremely handy to use. I can tell you for a long time in my engineering career, when I was working with design software, I was like, why do I want layers? I would just draw everything right over top of each other. And it wasn't until later my machine designs got more complex. It's like, oh, I need to put this somewhere else. I need it out of my way. The cut feature and working with shapes. Shapes, of course, enables you to make circles and rectangles, and cut and allows you to cut lines away from your thing. And all softwares, the design, the CAD softwares have these elements in them. Now layers, as far as easel, I'm not sure. Easel I've tried to mess with a little bit, but it's challenging. Things to consider when you're doing your design work is as you get better at it, you're going to start to think, how am I going to be making this? How am I going to cut it? What order am I going to be cutting things? What order am I going to use my router bits? And so as you're forming your project in your mind, you want to, especially when it becomes a complex project, that's what's holding me up on this flag, is I really have to think it through as to what kind of order am I going to be working in. So when I talk about order of operations, I'm going to do a video on that. But order of operations is we don't want to cut out the profile of this sign until we're done with everything else. And so everything else is in the order of operations is going to get done first. I just said that. So, but ironically, what I did do, you can see on this sign, was I've got a radius around the edge of the sign. And in this program, that was the very first thing that I did, because I just wanted that rounding bit out of my way. And so I just made it first. It was the least of the details I needed to worry about. And it was one I could use at any time in the program. So where order of operation comes in more important is when you're doing multiple different levels, like stacking your texts and things like that, which I'm going to do a video on as well. So that'll be a couple more weeks. I'm actually looking forward to doing that because a lot of people have asked for that. But that's where that's really going to come in handy, or where you need to clean out things. I'm going to show you another project, if I can find it, where order of operations became kind of important. Let's go to my models. So remember where I put it. I got a lot of stuff going on here. I think that's where it's at. Welcome sign. Okay. Let's open that up. This is actually, if any of you bought the router bits, you have this project. So in this one, when we are, I'm going to run this out real quick. This has lots of different features to it and requires lots of different tool paths. Just in this brown area alone required 3 different router bits: a 1/4 inch, a 1/16, 1/8 inch, and a 1/16 inch. At the same time, I have V-bit work going on here. I've got holes being drilled here, the profile. So the holes are 1/4 inch holes. That can be done just before the profile cutout, as opposed to putting a 1/4 inch down bit to start the holes, then switching over to some other 1/4 inch bit and then come back to it. But unfortunately, because there's a lot of 1/4 inch work within this area, and this area has to get done before the cutout, the profile happens, that means that bit would be put into the router at least twice. Ideally, we like to avoid doing that, but that's part of CNC work. Sometimes we just have to do that. What I find a lot with CNC is they don't like the idea of running their machine more than they have to. Like, some people want to get everything done in one pass instead of running a finish pass. But finish passes in my CNC work through all my years is just a gimme as part of the process. So don't be afraid to do a finish pass if you want to get better results out of your machine. And think about if your bits can support the detail. If you've got really ultra fine cutouts, do you have the bits to be able to do that? I made a sign that was extremely detailed, and I didn't have the bits to do it. So I had to actually go out and buy the bit. I had to buy a 1/32 diameter end mill. So when you're doing your design work, can it support the detail? And then think about what kind of detail you need. And what I mean by that is, if you're making something, sometimes we want it to be ultra super crisp, but do we really need to do that? If you're making a big sign, it's going to be outdoors, it's going to be hanging up high. It's not the fine details that people are going to see. They're going to see the rougher details. And so when you're considering your design, consider the use and what the end user is going to be seeing, and that can actually save you some time. And then think about runtime. The more detail you have, the more time it's going to take to run. That welcome sign, I think, took 2.5 hours to run because it had multiple passes all around the same area, and it had to do a lot of fine detail work multiple times as well. So it was a learning curve when I created that. That was early on in my CNC router stuff. So when it comes to bits, I'm guessing everybody's got an idea of what bits do what. Now, you know that I sell the set of bits that's on the left there, but you have the V bits. generally you have V bits, you have ball nose, end mill, the surfacing bit, and your carving bit. So the one that you're going to use the most common is your end mill. That the end mill basically just does a lot of pocket cleanup, or it's going to cut out the profile of your signs. And the smaller your end mill, the more fine detail you can get. The V bit, as you know, does lettering and other swirly types of things like right here. So the V bit does everything inside of this sign. It does the outline, it does the cup, it does the words. The thing is thinking about what size V bits you want to use, or what size bits you need. Again, it depends on the detail. Now you see I've got something that's kind of overlapped there. I added that this morning for this video, but it did not go where I wanted it to, or for this webinar. A 90-degree V-bit is not going to carve out letters that are 1/4 inch tall. Okay, this is where you need to move now to a 60 or a 30. And one of the things I recommend on V-bits is to build yourself a gauge where you'll have a board and you'll write a program or set up a program where a 30 degree will cut at a 0.01 inch, 0.02 inch, 0.03 inch, and they're staggered lines. And that way you know what kind of depth and width you're going to get out of that bit based on some of your settings. And you do that for the 60 degree as well and the 90 degree. And that'll be a good reference gauge for you. So if I'm looking at a something like closed Christmas Day and it's only a 1/4 inch tall, I'll be able to look at my gauge and say a 90 degree is definitely not going to be able to handle that at a 0.01 deep. So does that make sense so far? Okay. Now your ball nose, I find that those are used for two things. One is like profile, like I did on that coffee sign, and the other one is for carving. So I'm going to go to the next picture for a minute. So right down here, we have the rooster, and that you can do. This is actually like maybe 4 inches in diameter, and I did it with an 1/8 inch ball nose before I did it with a carving bit. And the ball nose came out with very fine detail. The carving bit comes out with much better detail. But that's generally what the ball nose is for. It's just to add accent to your projects or to soften up corners. You can use a ball nose in the lettering so long as your letters are going to allow for the size text that you're working with. Since everybody's V-carve users here, you'll know that when you generate your tool paths to see what it looks like. And then there's of course, the surfacing bit, which is to clean up surfaces, to surface your spoil board. Surfacing bit is intended for taking care of a lot of material at one time. And that's why they call it a surfacing bit. However, you get the right bit, you can do some other stuff with it. So I'm actually, I've got a video for that one out there, but I'm actually just got a batch in where I'm going to start selling these too. And then you have the carving bit down here, and the carving bit does the detail like this rooster does, and it actually does a really good job. The trade-off using a ball nose, like an 1/8 inch ball nose or a 1/16 inch ball nose versus the carving bit, is the amount of time that you're going to have that machine run. On this little 4-inch rooster, took an hour and a half. Something popped up on my screen. All right, took an hour and a half to run out. So, and that still wasn't done, and that's done with a carving bit. So you want to keep in mind how much time you actually want your machine to run as well. Some carves, the larger ones, can take hours. I mean, like I've written programs that took 11 hours, and I said, well, I'm not going to do that because that's just too long. It depends on the detail you want to get into, like the picture here on the left. That was done with a 30-degree carving bit. That's going to depend on what bit you select. And of course, if you saw the clamp video, then I just did all that with one end mill. It's always nice to keep it as simple as possible, but your design is going to dictate what bits you have to use and how long it's going to take it. But don't be afraid to go for it. Come up with your creative design. So I said bits example here. I just showed you a bunch of examples. This slide shouldn't be here. So any question on bits at this point? All right. So then, oh, come on out. You have to click your microphone. Yeah, just if you have a question, just unmute and come out and ask.
Okay,
There you go.
now you can hear me. I see where you're selling sets of bits. Are you selling individual bits?
Yeah, I'm actually I've got a box of them right here. I just haven't put them up on the on my website yet. So yes, I am.
Okay.
Yeah, I'll send an email out to let everybody
And I guess I have another question on
ask away.
the router bits that I already own. Can I use those in the CNC? Because I have a bunch of straight
Okay.
router bits from 1/8 all the way up to 3/4 of an inch.
Mm-hmm. So you can use it. What CNC do you have?
I have the Next Wave Shark 120.
Okay. Okay, so that's a fairly robust machine. So you should be able to work with your straight router bits.
Do I have to ramp them in?
Well, yeah, absolutely, because they don't have a bottom cut on them. So absolutely, the rule of thumb is to ramp half the diameter of the bit. When you're using that kind of bit, I would ramp the full diameter of the bit. So let me come over to my software here, and so I have to move you guys out of the way here. Okay. Let me find this one. We'll just do the cutout. Is that what that one is? Let's see what we're looking at here. Okay, I don't want that one. Okay, so let's just say you have a 1/4 inch diameter bit. And this is on a profile. This is cutting out the profile of the sign. You want to come down and go to your ramps area, select that, and you can use the smooth ramp. You want your distance to be at least 1/4 inch. With those bits, I would probably go twice the diameter of the bit, because there is no down cutting action in that bit whatsoever.
Okay, thank you.
Yeah, you're welcome. Yeah, go ahead and try that before you buy other bits. The thing, are your bits high speed? I'm almost certain they're high speed steel, because they're all one metal, right? The shaft and the body.
No, I've got some high-speed steel and I've got some carbide and I've
Yeah,
got quite a variety of straight bits.
Yeah, well, work with those. So the one thing that I do see with straight bits, if it's not sharp, you're going to get a lot of bounciness on there. The thing I don't like about straight bits is it's not using the shearing action of the cutting blade as a spiral bit would. Instead, you're coming in with the entire blade in one shot, and it's trying to work that entire surface. Now it'll work. It works on your standard routers. It will work in a router machine. It's just what's happening is your forces are a little bit different, because you've got a moving component that's got lots of moving parts on it that's trying to move around. So you may notice a little rougher finish and it may be a little more challenging for the machine. It actually is very distinct. It's kind of like trying to, with a drill bit, using a hand drill and drilling a hole is very different from holding the drill still and spinning the part to move into the bit, if that makes any sense. So it's kind of along the same lines. Just keep an eye on it. Watch for your material to be doing a lot of bouncing like that as the bit is trying to go through. But I would say go give it a whirl first.
Thank you.
Yeah, especially if you got a bunch of bits. I've got high-speed steel bits, and I don't use them. At least not in my machine. It's not rugged enough to handle them. So, any other questions? Okay. So one of the things I can't stress this enough is be aware of your setup and how you're going to be holding things down. So looking at the image to the right first. Now I'm going to expand this. So the image on the right, you see the black lines. And so the router head itself is at the home position. And I've drawn black lines to the farthest corners of the cuts directly. And so what I do is I paint a mental picture in my head of where that router can possibly move based on the home position from its maximum outside cutting areas. So in the case of this one is in the cross, you got the far right, that would be a straight line, the far bottom right corner and the far bottom left corner. And so I think you understand this is a window that I create in my mind as to where I can clamp this part at. Now, I'm just going to redo something here. I can refer to this like that and then draw another line across there, which is exactly what it's going to do. But I just like to be aware that I've got a clamp collision possibility set up here with this clamp in the top. So I want to be very aware of that. So whenever you are setting up your clamps, you just want to keep in mind where your clamps are positioned relative to where your CNC router can move to. Now, in this case, if we set the zero position at the center of the cross, then it's not going to hit the clamp. However, I still have this possibility of the router wanting to go to the home position. If my post processor has a G code in it that's what's called a G28, what that's going to do is send the router to the home position. And if the final cut in this case would be the top right corner, and it's done, it's going to pull up and it's going to start to wrap it back towards the home position and potentially could hit the clamp. So that's where you want to take into account the picture on the left, which is the clearance of your clamp and your router or your router components, like the router nut. If I was going to do a cutout on this cross all the way down to the bed, then the nut would probably hit the clamp. So you have to keep in mind all the moving parts and the 3 dimensions that your router is moving in. I had a thought in my mind and I just forgot what it was. Yeah, so anyway, that's in order to make sure you got something like this under control, that's where you want to work with your safe Z height. And I am going to, again, do a video with that as well, but just so you guys understand where we're setting this up at, is when we are in the toolpath area up in Vectric, there is this set button. And this is where you can relocate points, or your start points. Like if you're designing from the middle, like that, and then you are going to zero from the corner, then you change it here. If you are going to set from the top of the material or the bottom of the material, and your safe Z is down in this area here, down towards the bottom. So it's your home start position. I always leave my X and Y at 0. That's the home position. And that would also be the 0 position that we set. And then the Z gap above material. You always want to have that set higher than your clamps. That's your safe Z height. And if your clamp is going to be 3/4 of an inch over the top of your material, then you want that to be set at 1 inch. And that will keep you safe from collision on your clamps. Even though you still have that picture of that travel in your mind, like over here, you're going to be pulling up and over that clamp. I can't stress this enough because everybody runs into their clamp at some point or another. And this will save you from breaking bits or ruining clamps. But if your router is going too fast and it hits that clamp and that clamp doesn't move out of the way, you're going to break a bit. And that sucks. And then finally is the Z0 position. Sometimes we set off the spoil board. Sometimes we want to set it off the top of the material. It really depends on what you're trying to achieve. If in your project you're doing a cutout, like if you are going to make a sign like this coffee sign, and let me just regenerate this. Okay, so I've got part of this coffee sign where when it's doing the cutout, let's turn it right. It cuts out all the way through the sign right here. And it does that all the way around. So when I go to generate this G code, I want to set my Z0 off the bottom of the material and then tell Vectric in the set area that we are working off the bottom of the material. And what that will avoid is all these cutouts that you see in the bottom of my spoil board right here, where I either didn't take into account that the material was not the thickness that it was listed at. Like if you bought a 3/4 inch pine plank, it's never going to be 3/4 of an inch. And by the time it's done doing the cutout, you're going to have all kinds of lines in your spoil board. So that's when you want to zero off the bottom. You want to zero off the top if you're not going to go through it. It just makes it easier. One of the other times, if I'll zero off the bottom, if I'm going to make multiple of the same thing and they may have some varying thicknesses, like this piece of oak that's right here. I've got a bunch of it, but they're all different thicknesses. They go from like 1.3 to 1.5. So I would just take the thickest one, use that as the thickness of my material, and set off the bottom, and then do my work from there. Or I'm just gonna have to re-zero every time I need to put a new board in. There's just lots of different things. But ideally, it's better to zero off the spoil board and tell Vectric that you're zeroing off the spoil board. That way you don't cut into it and you don't end up with such a messy spoil board like mine. And I think I've got that. So we covered, going back to the beginning, we talked about how a CNC router works. And we talked about G code, and so I hope you guys have a concept of what G code is. A little bit about design basics. You just want to just keep an idea of what you're trying to achieve with your design. A lot of times, the more complex our designs get, it's hard to come up with a set of order of operations until after the design is done. And then you have to kind of backtrack and how am I going to put this together? And you might have to change things. But up front, it's just nice to know how detailed I want to get and what kind of, what am I going to try to achieve? And then you can get an idea of your order of operations from there. Basically, order of operations, you're working from the inside out. Router bit selections, it depends on what you're doing. Either you're doing V-carve, you're doing flat cuts. If you're doing nice, elegant little accents or surfacing, or you're doing really high detailed, is what's going to dictate what bits you use, and the size of your cut is going to dictate the size of the bit as well, particularly in V-bits. The thing with V-bits, just want to say the size of your letters is going to make a difference. If you haven't done it already, you'll make a letter too big, a big letter, and then you put in the wrong bit in there. You just go with a 60 and it's cut almost all the way through your board in order to get that whole carve out. So that's where you want to take that into account. And then setting up a job, you want to like just visualize where your router can potentially travel to based on the outermost edges of your design. And I always just try to keep my clamps completely out of the way of that box, that envelope that I've created in my mind. So there's one other thing I wanted to show you on that last image. Some of the other clamping methods that you can do. If I can find that image. Okay, so on this one over here, you can see I get clamps on the sides as well. These are not actually holding the part from the top, they're bracing it from the side. Typically, a router, the home-based routers aren't strong enough to push your material so long as you have a clamp down tight enough. However, it's a nice safeguard because I have had things move on me when I'm cutting things, and sometimes you're running for 4 hours and then something happens and it moves on you. That's kind of a bummer. So I always try to clamp down at 3 points instead of 2, and I find that 3 points are almost always adequate for the size bits that I'm working with, which I never, well, I can't say I never work with anything bigger than a quarter, but if I'm using something like a bull bit that's 5/8 in diameter, then yeah, I'll go with 4 clamps. So, yeah, that was pretty much the summary. So, first of all, questions.
I just wanted to tell you that I followed your clamps video.
Yeah.
And I really like using the layers. Took me a little bit to learn it, but I see why you did it and really made it come out pretty good.
Good. Good. So, did you make clamps?
I didn't put it on the router yet. I didn't put it on the machine. I
Okay.
got the program done. I just don't have it in the machine, and I got to go get a piece of wood to do it. So.
Okay. Yeah. So the clamps, I wonder if I got that brought up here. I don't have that brought up. I think I can open it up. I'm getting a lot of Vectric designs opening up here. Let's go to the clamps for a moment.
I could use plywood on that, couldn't I? Instead of just pine.
You can. The thing with plywood is because it's ply and it's stacked, and ply is stacked. The grain is that way, then it's that way, then it's back and forth like that.
Yeah.
You're starting to get some weak spots in it. Plywood will work, but you don't want to go too thin on that. Plywood is good for rigidity, but it's not good for like this type of action.
Okay.
So if you keep them short with plywood, you'll be okay. I mean, you can try it out, just do a plywood and see what it looks like, and see how they work. Personally, I don't personally recommend it. I'd rather have a straight full grain, one type of wood, and that's consistent throughout. I'm going to bring up the clamps because I did want to, since we talked about layers for a moment. Let's open that up. And I'm going to share my screen again. Okay, so with clamps, I've got 3 different layers here. And the whole purpose I made 3 different layers was to just make it easy to run out the tool paths. You saw in the other example the flag, which is right here, where it's got a lot of stuff on top of each other, including a bitmap, that I want things out of my way while I'm working on something. So going back to the clamps, I used multiple layers to make it really easy to pick my slots. So if I just wanted to create the first tool path, I've got to pick one item at a time to get through there. But when I turn the layers off, now just everything that I want to cut with that tool path is right there, and I select it all, and I'm ready to go. So that's one of the biggest advantages. The 2 advantages of layers are so you can for toolpath selection, where you can just select everything at once instead of having to pick through individual items at a time. And the other one is when you're doing really complex designs and there's lots of stuff over each other and you want to clean up some of that noise. So yeah, that's how you want to do layers. And the other reason I did the layers with the flag, let me close this, is because with this flag here, the first thing I did was build up my rectangle, then my stripes, and so I just want it separated. I want my stripes to be the stripes. I want the union to be the union, and be able to manipulate each one of those. It's like just sorting everything out. It just makes it easier. Okay, other questions?
I got another one.
Fire away.
I was following I sent you an email with the dragon that I did. And
Yes. Yeah, I needed actually.
And that would go to your material setup, or I'm not sure what I did wrong there. So.
Okay, well, we'll take a minute. So let's see. I don't want to mess with my flag program, so let's just come over here. I don't want to mess with. Actually, I don't want to mess with any of these things, so I'm just going to open up a new one. So I say file. So the dragon was one of the 3D vectors, right?
Yes.
Okay. So, sit down and model in. No, it's gonna be down clip art. So your dragon was
Under animals.
Yeah, no, I'm remembering your picture. So it was like a big bowl type of thing, and there wasn't a lot of detail in it.
No.
So yeah, so this little webinar is not really meant to dive into that kind of stuff.
I was just thinking about your material setup, the way you said it, where you put to the bottom of your board, or the bottom of the your spoil board, or whatever.
Okay. So when it comes to that, when you're doing, let's just find the dragon. Where are you, dragon? I guess dragon would be towards the top, so it starts with a D.
It's under Chinese dragon.
I'm not seeing it.
Yeah, me neither.
I've got it in here, because I have seen it before. Either way, is it this nature where it's got the big round thing around it?
No, it don't have that at all.
Okay, so
It's more like the rooster.
It's like
right
that
there.
one. Okay, all right. So that's why come on, get out of the way. So what is the problem you're having with your Dragon?
It just doesn't seem right. There's,
Okay. All right. So now that I know what you're working with, I did see your email, and I because I had to sit down and spend time with it, which I haven't done yet,
Right.
to try to answer your question. That's why I didn't get an email back from me. So I am putting that on my list as well. So I have 2 assignments now. I've got to get an answer for Gerbil, specifically what it is, and then with the Dragon, I will work through your Dragon because I want to see what's going on with that. Will you do me a favor and email your vector file to me?
sure.
Okay, because I want to see exactly what you got set up. And then,
Okay.
okay. All right. Other questions?
Yeah, I've got one. I'm having problems with depth of cut.
Okay.
If I set up a VCarve file and I do it in different, if I've got 3 different things I want to cut, they don't all come out the same depth.
Right. Okay. So that's what are you trying to cut?
Well, I was cutting letters, I was cutting profiles. I had a clip art that the clip art maybe went in 1/16 of an inch, and the letters right next to it went in 1/8 of an inch.
Okay. All right. So that part of that depends on the width of your letters, especially if you're doing a V carve.
Mhm.
I'm going to exit out of that. And I'm going to open up the coffee shop. And so if you are, let me change a little bit on this design. So okay, so I just changed Monday through Saturday to bold. And let's see, I'm actually going to do this a little bit differently. So just so you know, all this text is like the coffee crafted house is crafted coffee house is all one text function. You can right click it and hit the line break at text lines, and that'll separate them out. So now I've got crafted as one word, coffee is another word, hours is another word. And I'm doing this because this font is all the same size. If I go back in to change this coffee to bold, and now you can see the coffee C is much thicker than the crafted C. And so that means that right here, if I use a V60 bit on this coffee will probably be maybe 1/4 of an inch deep. But if I use that V60 bit here, it's going to go probably all the way through the material. And so the reason you're having issue from one text to the next is because you likely have different text sizes, or one may be bold, one's not. The other one would be is if you're trying to do V grooves with maybe this swirl in the saucer in a coffee cup. If you're trying to V carve that out,
Yes.
then you have to take into consideration the widest part of that as opposed to the average area, like right here. Because maybe around here it's going to look good, but when you get over here, that V is going to get deeper and deeper and deeper and deeper. So when you're having that, look at your font sizes between your letters, and then if it's something like the saucer, how does the size of that area that is V cutting out, how is that different? If it's getting wider and wider, then you're going to have to try a different bit. The other thing you can do is segment your things into 2 different things. So the crafted may be a 60-degree V bit, and then I would change the coffee over to a 90-degree V bit. That's the way I
Okay.
would handle these two words here. So is that answering your question at all?
Yes, I guess I'm learning.
Right. Okay. Well, let's walk through it again, because I want to make sure you get it. You know,
I was trying to use the same V-bit for both, and now it looks like I'm gonna have to change
Yeah.
V-bits.
Yeah. So that's actually a really good point. One of the things I would want to say is don't try to make life more efficient by trying to minimize your changeovers and your bits. It's you have to go through the setup and the zero of your bit again on your Z, but the quality of your stuff is going to come out better. I'm the same way. I don't want to change out bits. I want to do as little as I possibly can. But sometimes you just have to, and just say, okay, that's just the way I got to do it, and be okay with it.
And the other question I have is, almost all of everybody's drawings start with the center of the project. But then when they start setting up the tool path, they move to the lower left-hand corner.
Uh-huh.
Why?
Because it's easier to find the corner than it is the center of the material. So we are looking at this project here, and this board, let's just say it's 12 by 16. It's a lot easier to eyeball the router bit down to this corner here than it is to find your exact center on your board. I've taken a tape measure and I'd measured across the board, and I'll put a pencil mark, then I measure the other way, put a pencil mark, and then I try to center the router bit there. But one of the reasons that we do it like that is because also the machine home position is over here. When it really comes down to it, it's just easier to locate your zero on a corner rather than to find the exact center of the material.
Okay.
Yeah, so we design off the center because it's easy to center stuff. Let me just change my center point. So if here, I'll just go like this. Okay, so I'm gonna move all this stuff out of the way. And if I'm trying to make a new design and I want my design to be on center of the material, I can either guess as best as I can to find the center, or eyeball the center, or place things roughly towards center. The other way is I can just switch to center. And I'm not doing the greatest explanation here. Why is that not letting me do that? I got something open over on the other side. If you're trying to do some design work and it doesn't let you, that's because you have something open in your toolpath area. So let's just cancel that. Okay. And switch back. It's easy to design off the center because most designs are based on center, and you can just continuously just it wanted to redo all my tool paths. That's why it kept giving me all those alarms. Yeah, I already said it. It's easier to design things off of the center. And then when you go set up your tool path, it's just easier to set up your X, Y 0 point and your Z 0 point on the corner of the material closest to the home position of the machine. And I think you'll find that as if you design everything off center and leave it there, you're trying to find the center of your material. And physically, you'll put a tape measure on it and mark it out with a pencil or something like that. This way you don't have to. I don't know if I answered that question, did I?
Yeah.
Okay.
But the home position for my machine seems to always go to whatever my XY datum point is.
So when you say your datum point, your 0 point?
Yeah.
Yeah, there's two positions in a machine. There's the home position and then there's the zero position that you set. The home position is like the machine's reference position. When you turn your machine on, you have to send it home. And what that does, that tells the router, once it goes home, it says, okay, now I know where everything is at. I know where my X is at. I know where my Y is at, my Z is at. And then you go and move it and set a new zero over the center of your part or at the corner of your part. And you're not changing the home position. You are saying, telling them the software, I am referencing the home position by this X, Y, and Z distance. And I just lost train of my thought of my what I was just saying. They're two very different things, but they're both needed. When you are sending your machine to when you tell your router to go home, you are sending it to the home position that the machine understands as its 000 point that is referencing everything from. Your XY datum is your lower left corner of your job right here. Okay, so is your always going back to this point here?
Yes.
Okay. Now, if you at any time told the machine to go to its home position by using, are you using USG, Mach 3, what?
Next wave.
Next wave. Okay.
Next wave Shark 120.
Okay. What is that's the machine.
That's the machine.
What is the control software you're using?
I have no clue.
Okay. So do you have a box on it where you plug your USB into it?
Yes, I have a
Okay.
pendant on there.
Okay. Okay. All right. So I have not worked with that. So your XY datum is preset in your machine. I'll have to get on a little separate video call with you, just so I know how that stuff works, so I can answer a question like that.
Okay.
I got it in my head because I did it for a long time. And you have a pendant, and I'm so jealous. I want a pendant so bad. I think what's going on with your machine is it does need to know a home position. And every time you turn it on, you have to send it home. If you unplug it, if it knows where home is, then it's got like battery backup going on in there somewhere. Yeah, I'm not going to dive too much into that right now because I'll actually want to take a look and see what your setup is.
Okay.
Do we have other questions?
I do have one, Garrett.
Yeah.
Hi. I just started actually doing the V-carve toolpath,
Okay.
and I don't know if I've just been getting lucky or what, but you don't have to set any start depth or max depth, right? Because I've just been running it and getting what I'm getting. How do I know it's not going to go through my material?
You need to set a start depth.
Mine's always at 0.
Okay, that's your start depth.
Yeah.
And on the V-carve, so yeah, you always need to set a start depth, because if you have done already some work on your Z plane to take it down a little bit, then that's going to be your new start depth. The cut depth, so the depth of cut is going to be different. It's going to calculate out a V, where the V ends up the V ends up touching both lines of the letter.
Okay.
Okay. There's something called a flat depth in there, which I'm not going to get into here.
Okay.
But your start depth is 0 unless you're cutting down, like you're doing some milling inside of a pocket, and then you're going to start letters inside that pocket. Then your start depth is going to be a little bit different. It's going to be at that new depth.
Okay. So right now for my simple signs that I'm doing, it'll tell me if it's going to cut through my wood, right? Will Vectric give me an error? Okay.
Vectric does have that ability. It'll calculate it out, and if any of its calculations goes deeper than the thickness that you set for your material, it's going to give you an alarm. Now,
okay. I just wanted to make sure.
Just so you know, if you say okay, it's going to say okay, we're going to do it. And,
right.
Yep, and it'll calculate it out. So you have to cancel that and make changes if you don't want to start carving your spoil board.
Right. Okay. I just want to make sure because, you know, when you're doing a regular tool path, you have to put in, you know, how deep you want to go. And I've never told it how deep to go on the V carve. I just kind of let it do the start depth at 0 and let it do its thing. And then I thought, I don't know, maybe I've just been getting lucky.
Yeah, but now this was mentioned earlier. I think Chip mentioned it. If you're using a 60 diameter V bit on wide letters, you can cut a really, really deep word that will stop a tenth of an inch from the thickness of your material.
Oh,
It'll
wow.
be super, super deep. That's
Okay.
where the angle of your tool comes in is
Okay.
important.
We've been using 90s.
Okay. So 90 is a good catch-all
Okay.
because you can recover from a 90. If your Z, if you run your 90 and it's not going deep enough, you can come back in with a 60 and cut it deeper.
Okay.
But you can't go backwards. You can't cut it with a 60 and go with a 90 because then
And
you'll
then
have this.
add, right? Tell my 90 to add some wood.
Yeah, yeah. Actually, I think I'll write a program and make it available so that will do all these V carvings at different depths, so you guys can create your own gauges. So you'll get a really good idea of what V bits do at different depths and how
Okay.
wide that V will be.
And what exactly is the difference between picking V carve and just your profile tool path? I guess I never understood the difference.
V carve has to work with the V carving toolpath. Cancel out of that. I was in V carving. V carving needs a closed vector. Okay, this box that I've got right over here, I could technically V carve that box. Let me move that over. Even though it's a big box, I can make it that big. I can still V carve this box using this. Oh, let's see. Let's have some fun. So I'll use a 90, and it's going to give me an alarm because it's going to say I can't go that deep. Okay, there's my alarm, and I'm going to tell it I still want to go that deep. And what it's going to do, it's going to do this long ass tool path. Okay, but you can see it's still trying to cut. So V carving needs a closed vector, and so your text is all going to be closed vector.
Okay.
Okay, you can't V carve a line, but you can profile a line, and profile is when the bit is it's going around a line. So if you wanted to, I'll move this over. If you wanted to V carve the word crafted, then you can, because everything, all the letters are closed vectors.
Okay.
All right. On the other hand, I could come in and do a profile on it, and the profile will trace out the lines of the letter. So if I did a profile and I just took let's go with a 60, and I'm just gonna go 0.05 deep. Select crafted and calculate it. Okay, and run it. So you see, it just did the outlines of the letters. That's what a
Okay.
profile is. A profile will follow a line.
Okay.
A V carve will carve anything inside of a closed vector.
Okay. So it actually would carves out in between those lines, is what you're saying,
Yes.
per se. Okay.
Yeah. Yeah. If I just came back in, I'll show you the difference. Let's go over to drawing. I'm going to take this guy and I'm going to copy it. Okay. And then we're going to V carve that. I'm not really changing anything. I'm just going to V carve it now. And I'll use a 6 to 90.
Boy, I'm sorry.
Oops. I'll need to be in that. Close. Yeah, I got the 90 selected. Okay. And I got crafted. Calculate. And run. Okay.
Oh yeah, that's much better.
Yeah, but that's the difference. I mean, but there's times where you want to do either one.
Right.
Okay, they each have their characteristics when you're doing this kind of stuff.
Gotcha.
And that's the
Okay.
beauty. That's the beauty of the CAM side, where you can look at your projects after
Right.
you've designed them to see not only what they look like, not only how is the tool path running, and is it going to is that bit going to actually cover it, but you can also see what it looks like.
Gotcha. Yep. Yeah, this is a great program. I really like Vetric.
Yeah, me too. Okay, other questions? All
So
right.
Garrett, I
Yeah.
have another question, Garrett.
Okay.
On the UGS platform, when I go to set my job up, I need to, can you talk about zeroing the Z axis?
Yeah.
and How I do
Okay.
that?
Okay. So I am not connected to my router here. So this is, and things aren't going to be active here.
Sure.
But that's okay. I can work with pictures. So I'm going to go back to this picture here. I'm going to open it up full blown. Where did I have that at?
I think that picture you're looking for is what triggered this question for me.
Let it pop up. Okay. So X, Y, and Z and UGS. So let's try to get a little clarity on the question. What when you're asking that, what are you looking for?
Well, I don't have a sensor hook up.
Okay, like a tool probe?
Yeah, like a probe. There you go. Thank you
Yep.
for filling that in.
I don't either.
And so, okay, good. Then
Well, I
don't
have
think
one, but I don't use it.
okay, that's good to know too.
Yeah.
And I really am just getting started in
Okay.
this. I've, told you before that. So, and I went to run a project yesterday, and it said that I was outside of the parameters, but I don't think that I zeroed the Z like I was supposed to. And
Okay.
so that's
So
what I'm wondering about.
yeah, okay. So Lori called me a couple times on this one. If you are going outside of your parameters, is this when you started your program, it gave you an alarm? Is that what
Yes.
you mean? Okay. That's because some part of your program or is going outside of the range of what your machine is capable of doing.
Yes.
When a post processor, the post processor doesn't really do this. This is the controller, and this is, I believe, where Gerbil comes in. Is there is a known limit that your machine can travel, and it's using limit. If it's a Bob's, it's got limit switches. It might have what do they call them? Sensors where it detects when it gets close. And then it's got some stroke. So in the Z, it has a stroke. Let's just say it's got a 3-inch stroke. And once it passes that 3 inches, I'm just come to a hard stop. I can't go physically can't go any further. Your controller knows this. And so when you start to run your program and it sees something in that G code that says, I'm going to 3.5, based on all the things that are set up. And it says, I can't go that far. I physically can't go that far. That's the alarm you're getting. So when you, in this case here, if we set up on the Z right here, and that bit is too high up. Let's just say I've got another 1/2 inch physical limit that I can go in the up direction from where it's at right now. And my G code says go up a full inch. I'm going to get an alarm because the machine, the software knows it can't go any further than 1/2 inch. So you're getting the alarm for either because your Z is not set right based on the motions that the machine has to make, that there was somewhere it is saying you're trying to go too far beyond what the machine is capable of doing. So the way to set that, what bit were you having trouble with that on?
It's an 1/8 inch end mill.
Okay. What machine do you have?
The E4.
Okay. And where were you set? Okay. So you probably just didn't set your zero right.
Right. I'm thinking that that's what I
Okay.
missed on it.
Okay. So, yeah. So usually when that happens is we'll go down and we'll touch our tool, right? And then we just forget to zero it out. We forget to tell the controller, okay, this is the zero. When you get your router bit in position, as it is here on top of this piece of oak, you stop and you go over to your USB and you'll just take your mouse over the Z right there and you click it. And what you're going to see is that big number will turn to zero. It'll be some weird
Okay.
number like 3.568 or something like that. When you click that Z, it'll flash red and it'll turn to zero. And when that is showing zero, while your router bit is in that position that you want it to be, then you'll be set up to go. And I'm almost going to guarantee you probably just forgot to set that zero, turn the Z to zero when you did that.
Yes, I think you're right about that. And
Okay.
thanks for clearing that up.
No problem. Make sure that when you get your X and Y in at the corner of your material or wherever you want your 0 point to be, that you do the same thing.
Zero those two.
Zero those as well.
Can you do those all at once?
Yeah.
On
Yeah,
there?
well, you can't, there's not one button. You have to click each one independently, but yes, you can do them all at the same time.
Okay.
All right. Any other questions? Okay, well, that's good because my bladder's about to explode. All right, so let me just end this. Was this helpful for you guys? Thumbs up if you've got something out of this. Awesome. And what I will do is you will get a recording. You're going to get an email in about an hour. That's going to ask you for some feedback. So if you just be honest with your feedback, what other information I can give you, what I could maybe done a little differently, whatever, because that'll help me make a better presentation next time. And what was the other thing I was going to say? Oh yeah. So I will send you an email too that gives you access to the link to this recording if you need to go back to it. But give me a day on that because I'm setting something up so you can always get back into that.
And Garrett, before you go, if I need to get a hold of you for one-on-one G code, how do I just send you an email?
Yeah, on my website, idcwoodcraft.com. There, I'll show you. Let me share the screen again. Let's just go into incognito. Okay. So on the website, it's right at the beginning. It says, "Are you a CNC beginner?" So you can click there, right there to schedule. And but I may be changing my website a little bit, so I might be taking this whole sentence out. I'm not sure. Otherwise, you can go to the online learning for beginners, and there'll be a link in there. I believe. Let me make sure. Yeah. Yep. That's what yep. So set up my training session. Look for that button. And that'll take you to a calendar where you can set up your one-on-one.
Okay, cool. Thanks.
Okay. No problem. I'm glad that that you find this useful in one way or another. I mean, CNC is amazing, and you can do some pretty amazing stuff. So, guys, I got to pee. So, I'm going to check out of here. We've been at it for what, an hour, 2 hours now, right? Yeah. All right. So, I look forward to projects. Make sure whatever you make, send me pictures because I love to see that stuff. And thank you for joining. And yeah.
Thank you.
Yep.
Thank you, Garrett. Appreciate it.
You're welcome.
Have a good day.
Bye, guys.